Here we go. Last topic, the difference of means. Every year, favorite songs compete to be on the top 200 list based upon sales and rankings by the experts in the music industry. These songs have many characteristics, such as song length and beats per minute, which vary from category to category in the music industry. A disc jockey wondered if the number of beats per minute in songs classified as dance music were lower than the beats per minute in the songs that are ranked on a top 200 list from 2001. A random sample of songs from each group was selected, and the beats per minute are listed in the chart at the right. Does this sample indicate the songs classified as dance music have lower beats per minute than songs ranked on a top 200 list? Test an appropriate hypothesis and state your conclusion. So our first thing, remember, is that we need to write our null and our alternative hypothesis. So I'm going to have my null as the mean number for dance. The beats per minute is the same as the mean in my top 200 songs. So I'm going to denote them with a D and a T. My alternative hypothesis, so I'm going to set them up, and I'm going to look back at my problem, and it says have lower beats per minute. So dance has lower than my top 200 songs. Remember that I could also see this written as there is no difference. So the beats per dance and the beats per top 200 songs equals 0. And if I did it the other way, when I subtracted, I would have less than 0 here because I would get a negative if I had less in my dance music. All right, now that I've written my null and my alternative, I can go ahead and check the conditions. And we're going to use this this way to write our null and our alternative. Conditions are very similar to a single mean, except I have to do it twice. I have to do it for both sets of my data. So the first thing, I want to make sure that both the data collections were random, and they are. So it says that they are random. I have a total of 33 songs combined. So my 33 songs is less than 10% of all current songs. I also need to make sure that both groups are independent of each other, and they are. So I can assume that one group does not affect the beats in the other group. Fourth condition, we need to check that both groups are nearly normal. And in order to do that, I need a histogram. And in order to check both groups, that means I need 2 histograms. So what you're going to do right now is hit pause, and then I want you to enter the dance songs beats per minute in your calculator in list 1. After you put it in list 1, make sure your stat plot 1 is on, and you want to do the histogram, and you want to make sure nothing else is in y equals. Hit zoom 9, but notice that your graph doesn't look roughly symmetric, so you have to play around with the window. So when I adjusted my window to get the histogram below, I had my x min as 117, since that was the lowest. X max was 123, because that was the highest, and my x scale I had as 1. I didn't have to change my y min and my y max because all the bins fit on my calculator. Then I'm going to hit graph to get the histogram I have below. Do not hit zoom 9 after you changed your window, or it's going to put it back to that original graph. All right, so this first histogram of dance songs looks roughly symmetric and nearly normal, so I've met that condition. Now I need to do it again with my second set of data, and I'm actually going to enter that in list 2. So go ahead, hit pause, and enter all of that data in list 2. Once I entered my data in list 2, then I wanted to look at the plot. So I went to stat plot, and I made it say list 2 instead of list 1. I hit zoom 9. I wasn't too happy with the way that it looked, so I changed the window. This time my minimum was 118, my max was 124, and I had an x scale of 1 to get the graph that I had. Since both of these are roughly symmetric and unimodal, I need to add that to my conditions. So roughly symmetric and unimodal. So now I'm set to go and run a test. This time in my calculator, I want to do 2 sample because I have two different things, two samples, and we used a t-test before it. So two sample t-test. So to get there, stat test, it is number 4. All right, we have data, and we have information in list 1 and in list 2, so we want to make sure it says that. Frequency is going to stay as 1 for both of them, and we want our list 1, which was our dance songs, to be less than our list 2. So we want to select the second one. For pooled, just keep it as no, we're not going to talk about that, and then go ahead and hit calculate. Information you should see reported. Your T is negative 1.45. My P is 0.0787. DF stands for degrees of freedom, but we're not going to talk about that either. Our X1, so that's our mean for our dance songs, was 119.72 beats per minute. And our mean, I'm actually, instead of a 1 or a 2, I'm going to put a T and a D. So dance songs mean, top 200 songs mean was 120.6 beats per minute. All right, based on this p-value, we can make our conclusion. Did you think that dance songs have fewer beats per minute than top 200 songs? If we set our alpha in the beginning to 0.10, we would say that we have a low p-value. So our concluding sentence here, with a low p-value, we reject the null hypothesis. Therefore, we have evidence to suggest that dance songs have fewer beats per minute than the top 200 songs. Creating and interpreting a 90% confidence interval is going to give us a better idea of what the difference is in the beats per minute. So in our calculator, since we've already checked our conditions, we're going to go to stat test, and we are going to go to 2 sample t interval, which is 0. Again, we have data, and all our stuff should be there for us. Data, list 1, list 2, 1, 1. Confidence level, we want to make sure that's 90%. Pooled, no. Calculate. And I get negative 1.906 to 0.15004. Based on this interval, since I had dance songs first, and I have a negative here and then a positive value, my concluding sentence is a little bit trickier. So we would say we are 90% confident that dance songs average between 1.9 fewer beats per minute to 0.15 more beats per minute than the top 200 songs. But I should note here that 0 is in my interval. All right, well, that kind of disagrees with what we did up in our hypothesis test. So because 0 is in our interval, I would actually say that there is no difference or no significant difference in the number of beats per minute in either of the types of music. That probably relates back to the fact that we chose our alpha as 0.10. If in fact I had said alpha equals 0.05, then my p-value would have been high and I would have failed to reject my null. So sometimes it is based more on our alpha here. So if you had said alpha is 0.05, then our results would have agreed. So it is important down here that you do note that 0 is in our interval, so we don't really see a significant difference. Example 2. A random sample of 13 men and 19 women in a college class reported their grade point averages. Here are the histograms from the data. Lucky you that you don't have to enter that yourself. So that condition is going to be already pretty much done for us. The summary statistics for these data are below in this table. A woman in class says she believes that college women tend to have higher GPAs than do college men. Does this sample support her claim? Test an appropriate hypothesis and state your conclusion. So we are looking to see if the average GPA of women and men are the same, or do we have enough evidence to say that women have a higher GPA than men. So now that we have our null and our alternative written, we need to check our conditions. It says random, so we're lucky there. So that's done. We're going to assume that both groups, that men and women, are independent from one another. We have a total of 32 students. So 32 students is less than 10% of college men and women. And our fourth condition is the nearly normal. I'm going to look up at my histograms that are already created for me and realize that they are both roughly symmetric and unimodal. So now that these conditions are met, I can go ahead and run a test. Now notice that I don't have a set of data this time. So I'm just going to have to change up how I select it in my calculator. So we're going to do a 2-sample t-test because I have two different groups. I'm going to go to stat test number 4. And this time I'm entering in my stats instead of data. So 2-sample t-test. The mean of group 1, which is going to be my women because I had them first, so this is group 1, is going to be 3.33. And my standard deviation for group 1 is 0.395, so I'm going to enter that in my calculator. And I had 19 women, so N1 is 19. For my group 2, I'm going to go ahead and enter my men. So the mean for men was 2.898. Standard deviation for men, 0.583. And I had a total of 13 men. I'm going to select women being greater than men. So I want my mean from 1 to be greater than my mean of 2. So it's the very last possible one. Pooled, no. Calculate. I get a t-value of 2.33. That should ring a bell here because that's a big, it's greater than 2. My p is 0.015. And everything else there I have already reported. So my concluding sentence here, with a low p-value, we reject the null. We have enough evidence to say that women have greater GPAs or tend to have higher GPAs than men. And we will use a confidence interval to figure out how much higher or lower, or how, in this case, how much higher women's GPAs are than men's. Okay, so to create a 95% confidence interval, I'm going to do 2-sample t-int. My conditions are already checked, so I can go ahead and run this test. So stat test down to number 0, select stats. The only thing we need to change here is our confidence level from our last problem, so I'm going to change it to 0.95. Pooled, no. Calculate. And I get 0.0446 to 0.8193. Both are positive, so that tells me 0 is not in the interval, so there must be a difference. So we are 95% confident that the mean GPA for college women is 0.045 to 0.829 points higher than the mean GPA for men. 0 is not in this interval, so this agrees with our hypothesis test. Well done. You now have learned all the types of hypothesis testing and confidence intervals that you need for your final project. So remember, by Wednesday, you need to tell me what you want to do for your final project. It can be a difference of proportions, or it can be a difference of means.